Okay, in one of the last videos I made for you, I made a midterm exam review for you. And what I did on that review was I just popped it up and just told you just to copy the whole review. I told you to make several copies of it. It is still on that video if you want to go back and look at it. What I'm going to do now is something similar to what I did with you then. I'm going to pop up the same review, except this time all the problems are going to be completely worked out. So when I show it, you'll hear me say pause. Pause the video and copy what you see. After you get through copying it, play it. And then you'll hear me say pause again. And so we're going to go through every one of the problems, and I'm going to let you first just get them all copied down. Then I'll come back and go through all of the problems with you. Okay, so here we go. The first problem, a group of problems that you had on the review was solving equations. And there was 4 problems, I believe. Five. 5 problems on solving equations. Okay, so here we go. Here is the first one. Pause. Here is the second one. Pause. Here is the third one. Pause. Here is the fourth one. Pause. And here is the fifth one. Pause. Okay? Now the next one. Roman numeral number 2 is find the perimeter. Pause. The next one was a rectangle. Pause. The next one was a reading problem. Pause. The next 2 problems were inequality problems. Pause. And then here's the other inequality problem. Pause. Then we had 2 other inequality problems that were compound inequalities. Pause. And then pause. Okay, the next 3 problems were absolute value equations. Pause. Part A. Part B is quick. Pause. And then part C. Pause. Next problem went into graphing. I'll have to look and make sure you can see all of this one. Yes. Let's see. I think you can get that now. Let me check. Almost. Give me just a second. Just a minute here. X, I, Y. Okay, pause. Okay, this next one, I'm going to show it to you in 2 parts. I'm going to show you this first. Pause the video and copy this. Now, you just copied this. Now draw the graph out beside it. Pause the video now and copy this graph. Okay? And then on the next one, here was the problems right here. Graph these 4 lines. Pause the video and copy this. done. Okay, the next one. Find the slope of the line that goes through the 2 points. Pause the video. Okay, now pause the video again. And then the next section, which is the last group, find the equation of the lines. Here's part A. Pause and copy. Part B. Pause and copy. Okay, part C, we're going to do it in 2 stages. Part C, pause and copy this. Now, after you've copied that, over to the right over here, copy this right here. I'll show you where that comes from when we go through these examples. Part D, this one, pause. And then last, part E, pause. Okay. So now what I want to do is I want to go back through these problems and just go through each one and remind you of where these steps come from. Okay, on this very first problem, solve the following equations. This is where we get our x's on one side, numbers on the other. So this is a 2-step problem. So we're going to subtract 3 from both sides. That's how the minus 3 gets over here. And then minus 5x to both sides. Now I told you can do that in 1 or 2 steps, whatever you're comfortable with. And then 7x minus 5x is 2x equal negative 10. Divide by the number in front of x to get x equal negative 5. Okay? This next one. It's all up here. Yeah, okay. All right, on part B here, start out, 3 in front of the x, distribute. 3x minus 3, bring down the plus 2x, 7x minus 21. Then add the 3x and 2x together, get 5x minus 3, bring down the 7x, negative 21 plus 8 is negative 3. Then get your x's on one side, get your numbers on the other. So this would be negative 2x equals 0. Divide by the number in front of x, and 0 over any number is 0. If you've forgotten that, take your calculator and you'll see where that comes from. Now, on this example C, it's cutting off so much of that. Give me just a second. Okay, here we go. All right, on example C here, in this problem right here, you're not distributing with the 3. You're distributing with what's in front of this grouping symbol, which is a negative. More specifically, a negative 1. So you're distributing this grouping symbol with a negative 1. So bring the 3 down. Negative 1 times 2 is negative 2x. And negative 1 times negative 4 is plus 4. Equals. Over here, bring the 6x down. You're distributing with this 8. This is 8 times what's in here. But don't lose sight that this 8 is negative. So it's negative 8 times x, which is negative 8x. And negative 8 times negative 2 is plus 16. Now the left side, bring down the negative 2x. And then 3 plus 4 is plus 7. On the right side, 6x minus 8x is negative 2x. Bring down the plus 16. Now you get your x's on one side, get your numbers on the other. Negative 2x plus 2x is 0, or 0x equals 16 minus 7 is 9. Now, when you get to right here, I'll just remind you of something. First, the 0 has to be here. If you leave the 0 off, it's understood 1. So the 0 has to be there. Secondly, to get rid of the number in front of x, we typically divide. But remember, in mathematics, you can never divide by the number 0. So I told you this when we covered this section. I said when you're solving these equations, if the variables cancel, not the numbers, not what happened up here, not this one. Up here, the variables didn't cancel. Here they did. I told you that if the variables cancels, one of two things. Either your answer is either no solution or it's all real numbers. One of those two. Now, how do you know which one? I told you to read this and see if the answer is everything works or nothing works. Well, let's read it. This says 0 times what is 9? Can you take 0 times anything and ever get 9? No. So in this case, it's no solution. Now, remember, if this had been 0x equals 0, it would have been all real numbers. So 0x equal any number is always no solution. 0x equals 0 is always all real numbers. And this was no solution. Okay, this next one. Equations with fractions. How do we deal with equations with fractions? Well, the first thing I told you to do is we don't like the fractions. To get rid of a fraction, which is a dividing number, you multiply by a number. But when you multiply, two things. You have to multiply each side, and it has to be by the same number. Now, when you multiply, you have to multiply by a big enough number that gets rid of all of your fractions. So if I'm going to get rid of a dividing 3 and a dividing 2, I got to multiply by a number that 3 and 2 both divide evenly into. That number is 6. There are other numbers that 3 and 2 both go into, like 12, but 6 is the smallest. So 6 in this problem is the common denominator. But what I want to do is I want to multiply. Now, you need to remember, when you multiply a side by a number, it has to be every term on that side. So, for instance, here's my equal sign. There are 2 terms here. So, when I multiply by 6, I have to multiply this by 6, and this by 6, and this by 6. So, I'm going to put a 6 here, a 6 here, and a 6 there. So, I did that in the next step. So here's the 6, here's the 6, here's the 6. Now, what's the purpose in doing this? To get rid of fractions. So let's do that. Take your pencil right here. 2 into 6 leaves 3. 3 into 6 leaves 2. Now, don't cancel here because both of those are in the top. So this is just 6 times 2, which is 12. All right, so when I do 6 times 2 is 12x. Now remember, we've marked out, take your pencil, 3 into 6 and change that to 2x. That's where that comes from. And right here, 2 into 6 leaves 3 times 1, which is 3. Then add the x's together, 14x equals 3, and then divide to get 3/14. Okay? Next example. Dividing 2, dividing 3, dividing 4. So I want to multiply through by a big enough number that 2, 3, and 4 all divide evenly into, which is 12. So the LCD is 12. Now what I want to do is multiply through by 12. When I multiply through by 12, this is one term, this is one term, and this is one term. So I'm going to put a 12 right here, a 12 right there, and a 12 right there. Now, let's cancel. How many times will 2 go into 12? 6. 2 goes into 12 6 times. Bring down the x minus 3. I will distribute that in the next step. Could you go ahead now and distribute that? Yes, you could. But I don't want to do 2 steps at once. So for that reason, I'll wait and distribute in the next step. Right here. 3 goes into 12. How many times? 4. But make sure you put what's left in parentheses. Not only that, don't forget that this 4 is negative. And then 4 into 12 is 3, and 3 times 1 I just went ahead and wrote is 3. Now distribute 6x minus 18. Be careful right here, you're distributing with a negative 4 times 2, and a negative 4 times a plus 1 is a negative 4. Add the x's together, 6x minus 8x, negative 2x. Negative 18 minus 4 is negative 22. Add 22 to both sides to get negative 2x equal 25, and then divide to get negative 25 over 2. Okay, next example. Find the perimeter. There's the problem. First, remember, the perimeter is the total distance around something. What do we know about a square? All 4 sides are equal in length. So the perimeter means add up the lengths of the 4 sides. So if this is 3x, this is 3x, that is 3x, and that is 3x. So the perimeter would be 3x plus 3x plus 3x plus 3x, which is 12x. Another way you could have done it is you have 4 sides, and they're all 3x. So you could have said 4 times 3x. But the answer is 12x there. Okay, this next one is a rectangle. What do we remember about rectangles? Opposite sides are equal in length. So this one is 4x minus 3. 4x plus 3. And this one over here is x. So the perimeter would be add all 4 sides together. So the first side is x. The next side is 4x plus 3. The next side is x. The next side is 4x plus 3. So this would be 4x. 4x is 8x. Plus another x is 9x. Plus another x is 10x plus 6. Now, it's not equal to anything, so that is your answer. Okay? This next problem. The next problem was an application problem. And here's basically what it says. The sum of 3 numbers is 30. That means if you add them together. The second number is twice as big as the first one. The third number is 2 less than the first one. Find the 3 numbers. Now, I told you in any application problem, there are 4 things that I always look for. Number 1, the first thing I look for is a heading. What does a heading mean? A heading is where you say, let x be whatever. Now, how do we know what to let x be? Well, remember in a reading problem, if you're asked one question, you let x be that. But if you're asked more than one question, you let x be the one you know the least about. So in this problem right here, we've got the first side, the second side, and the third side. It says nothing about the first side. So I'm going to let x be the first side. Now, if I let x be how long, let x be how long the first side is. I'm sorry, not first side. I'm getting ahead of myself. I'm still thinking about triangles. Let x be the first number, not first side. I'm thinking about a triangle here. So let x be the first number. Now, what does it say about the second number? It said the second number is twice as big. So if the first number is x, what would the second number be if that's twice as big? It would be 2x. Then what did it say about the third number? It said the third number is 2 less, 2 fewer, 2 subtracted from the first number. So if the first number is x, 2 less than that would be x minus 2. Yes, it has to be x minus 2 because it's 2 less than. The word less means subtracted from. Now, why do I have 3 headings? Because I have 3 questions. Remember, the question said find the 3 numbers. However many things you're looking for, you have that many headings. If you're looking for 1 thing, you will have 1 heading. If you're looking for 2 things, you'll have 2 headings, etc. So we're looking for 3 things here. That's why I have 3 headings. Now, that's my heading. That's the first thing that I look for. Second thing I look for is your equation. Well, it says the sum of these 3 numbers. What does the word sum in mathematics mean? It means if you add them together. So if I add them together, it's equal to 30. So add the first one. Here's the first one. Here's the second one. And there's the third one. If you add these 3 together, it's equal to 30. That's the second thing I'm looking for. The third thing I'm looking for is where you work it out. Well, x plus 2x is 3x plus 1 is 4x minus 2 equal 30. Add 2 to both sides to get 4x equal 32. Divide both sides by 4 to get x equal 8. So that's the third thing I'm looking for. Number 1 is your heading. Number 2, your equation, this line right here. Number 3, where you worked it out. Now number 4, your concluding statement. Well, what did we let? I told you when you go to write your concluding statement, always look back up at your headings. Okay, my headings, I had 3 headings. So I'm fixing to have to make 3 statements. First, x was the first number. We just found x. X was 8. So that means 8 is the first number. So the first number is 8. Now, what does it say about the second number? It's twice as big. So that's 2 times 8, which is 16. Then what did it say about the third number? It's 2 less than the first one. The first one was 8. So 2 less than that would be 6. And if you wanted to double check it, if you add these 3 numbers together, I do get 30. Okay, so I'm going to stop there. And we will pick up with the video and continue on with the next group of problems, which was inequalities.